Right, welcome back. Here we go. Simultaneous equations. This was one of the topics you practiced last week when I was off with COVID. So the first thing we do is number our equations. The top one we'll call equation 1, the bottom we'll call equation 2. Then we're going to make our x's the same. We do that by multiplying equation 1 by the number in front of the x in equation 2, and equation 2 by the number in front of the x in equation 1. So we'll take equation 1 and multiply by 6. And we have to multiply every part of that now by 6. So we get 24x minus 6 3s are 18y equals 12. Okay, so 6 4s are 24, 6 3s are 18, 6 2s are 12. And then we call that equation 3. Then equation number 2 we multiply by 4. 24x minus 5 4s are 20 y equals 4. That's equation 4. Now we want to get rid of the x's, and we do that by subtracting, and we're going to do 3 take away 4. So if you imagine here now that you've got in a big subtraction sum, we got 24x take away 24x, gone. Nothing. Here we've got minus 18y take away minus 20y. Okay, so I've written that out just because it's important that you realize that I'm subtracting a negative number that's going to become positive. And on this side I've got 12 take away 4, which is 8. So I've got 18 minus 18y plus 20y equals 8. Negative 18, go up 20 places, you end up at 2y equals 8. Now you're going to divide both sides by 2 and get 1y equals 4. So y is 4. What we then have to do is to get rid of the y from one of our equations to work out what x is. Okay, so we substitute 4y in, and I'm going to go into equation 1. So equation 1 now becomes 4x, and then instead of take away 3y, the y becomes a bracket with a 4 in it. So 4x take away 3 lots of 4 equals 2. 3 4s are 12. I then want to get the 4x and so on, so I have to get rid of that by adding 12. I add 12 to that side, I add 12 to that side as well. So 4x equals 14. X equals 14 divided by 4. And you can leave it like that, or you can simplify it. That's the same as 7 over 2. 7 over 2 is the same as 3.5. So y is 4, x is 3.5. Question 9, surds. Calculate the correct answer for each of the following statements. So root 7 to the power of 4. Anything to the power of 4 means it's being multiplied by itself 4 times. And if you multiply a root by itself, it just undoes the root. So root 7 times root 7 is the same as 7. So those combined become 7, and this becomes 7. So you end up with 7 times 7, which is 49. 12 to the power of 0, anything to the power of 0 is equal to 1. Okay, that's one that I banged on about when we did indices. The square root of 3 squared times 5 squared is equal to, well, you could work out that 3 squared is 9 and 5 squared is 25, and then from there, in fact let's do it that way. You could then work out what that is and work with a big number. But one of the rules of surds is that if you've got, and this is how I've written it on your notes, if you've got the square root of a times the square root of b, that's the same as the square root of a times b. Sorry. But it works both ways. So the square root of a times b I can open up into the square root of 9 times the square root of 25. And the reason I want to do that is because I know, I've recognized that 9 is a square number and 25 is a square number. Square root of 9 is 3, the square root of 25 is 5, which means that is 15. Okay, so there's several different ways you could have gone about doing that. 3 to the negative 4 is equal to, right, negative power, that's your reciprocal. Okay, we met a reciprocal in an earlier question, so that means turn it upside down or put 1 over. So 3 to the minus 4 is the same as 1 over 3 to the power of 4. 3 to the power of 4 is 3 times 3 times 3 times 3. 3 3s are 9, 9 3s are 27, so I've got to do 27 times 3. 7 3s 21, 2 3s are 6, 7 8. So it's 1 over 3 to the power of 4. 3 to the power of 4 is 81, so it's 1 over 81. 4 times 2 to the power of 28 can be written as 2 to the power of n. What is the value of n? Well, I know that 4 is 2 squared. So I can write the 4 as 2 squared. Then using my laws of indices, when the bases are the same, I can add their powers. So that's the same as 2 to the power of 2 plus 28, which is 2 to the power of 30. So 2 to the power of n is 2 to the power of 30, so n is 30. Okay, if you haven't revised certain indices, that's a horrible question. It doesn't take long to revise. Question 10. So this is form equations in context. Again, it's something you did last week when I was off. The cuboid has sides x, 5 and 7 centimeters. The total surface area is 142 square centimeters. Form an equation in terms of x. Solve the equation to find x. So a cuboid, I've given you space up here just to draw a little sketch, is a rectangular box shape. So it's got sides x, 5 and 7. Now it makes no difference whatsoever if you label that with that x, that 7, that 5, it doesn't matter. It'll all work out in the wash, in the equation. So to work out the surface area, we want to work out the total area of all the sides. So this side here has got an area of x times 5, which is 5x, and there'll be an exact copy of that on the other side of the box. So that area is 5x, the other side is going to be 5x as well. This side is going to be 7 times x, which is 7x, and there'll be an exact copy of that side. So now I'm on the top of the box, and the top of the box has got a width of 5 and a length of 7. So the area of the top of that box is 5 times 7, which is 35, and the area of the bottom will be exactly the same. And the total is going to come to 142. So that's your equation in terms of x. I can simplify that now. I've got 5, 10, 17, 24x plus 70 equals 142. Take the 70 off, and I've got 72. So then I have to divide by 24, and I get x equals 72 divided by 24. We can simplify that a bit. We've got both of them are even, so that's going to be divided by 2 is 36, and that's 12, and 12 goes into 36 3 times, so x is 3. Okay, so that's an equation in context. That's very much an intermediate tier equation in context, probably grade C. Question 11, recurring decimals. So what we do is we write x as our recurring decimal, and then what I need is to write that in a way that I've only got the repeating part on the right hand side of the decimal. So if I multiply that by 10, then I'll get 3.7777. So if I multiply it by 10, I get 10x is 3 recurring. Now if I subtract those, because what I want to try and do here is get rid of that recurring part. If I subtract these, it won't get rid of the recurring part because this original bit hasn't got just the 7777. So I've got to do another multiplication. So if I multiply it by 100, I get 100x, and that will move point twice to give me 37.77, and so on. So when I subtract these two, that then goes, and I'm left with 100 take away 10, 90x, 37 take away 3, 34, and the repeating part is gone. To get the x on its own, I divide by 90, which gives me my recurring decimal of 34 over 90. Okay, back to surds. If you're squaring, you're multiplying by itself, which means we can write that like that. I'm doing root 8 minus root 2 times root 8 minus root 2. If I use FOIL, I'm going to have root 8 times root 8 first. Outside, root 8 times root 2, negative. Inside, same again. And then last will be root 2 times root 2, that times that, and minus times a minus is a plus. If I'm multiplying root by itself, that just becomes 8. This becomes minus 8 times 2 is the square root of 16, and another one. And then root 2 times root 2 is 2, sorry. It just becomes whatever's underneath. So root 8 times root 8 is 8, root 2 times root 2 is 2. Square root of 16 is 4. So I get 8 take away 4 plus 2. 8 take away 4 is 4, take away 4 is 0, plus 2 is 2. So the square root of 8 times the square root of 2 all squared is 2. Calculate root 6 divided by root 2, sorry, multiplied by root 20 over root 3. So that's going to be the same as the square root of 6 times 20 divided by 3. Okay, same rules. That times that is the same as the square root of 6 times 20, and you can bring in the square root of 3 underneath as well. So that's going to be the square root of 120 divided by 3, which is the square root of 40. 3 goes into 12 4 times. Give your answer in the form A and B, A root B, where A and B are integers and B is as small as possible. So what we then do, and we did practice this, is we want to break that down to write it as a factor pair where one of the numbers is a square number. And I can write 40 as 4 times 10. And 4 is a square number. So that's the same as the square root of 4 times the square root of 10. And the square root of 4 is 2. So that becomes 2 root 10. Evaluate 16 to the minus 3 over 2. So there's lots going on here. We know that the minus means that it's 1 over. So that's going to be dealt with that. The half bit tells me that it's a square root. So that's the same as the square root of 16 to the power of 3. I know the square root of 16 is 4. So that's going to be the square root of, 1 over 4 cubed. So the minus, we get rid of that by giving it the reciprocal, 1 over. The half we can deal with because it's a square root, and I can take the square root of 16. And now the power of 3 means 4 times 4 times 4, which is 16 times 4, which is 64. So it becomes 1 over 64. Minus 1 over half square root 3 cubed. Okay, question 12. Factorize and hence solve. So it isn't one where they say give your answer to 2 decimal places. So it's not the formula. So there's a 1 in front of the x squared. So I do 1 times 21 gives me 21. I then list the factor pairs of 21. There aren't many. 1 and 21, 3 and 7, 7 and 3, that's it. I want to choose the pair that I can make into plus 4. So to make plus 4, that would be my pair of numbers. I rewrite the 4x like that. I then deal with the first pair and see what I can take out as common, only x. And then for the second pair, I know that my bracket needs to be the same. So what can I take out of there? I can take, not 3, 7. 7 out of there. And I want it to be a plus to make 7x plus times a minus 21. I've got the repeated x minus 3, and in the second bracket goes my x plus 7. I then put that equals to 0, which means I need to choose a value of x which will make that bracket go to 0, which will be 3. So we say either x equals 3 or the value of x that would make that go to 0, which would be negative 7. Okay, a little bit harder with this one. So we've got some factorizing to do. We'll deal with the top of that first of all. So we multiply these two together and we get 8. We list our factor pairs of 8. 1 and 8, 2 and 4, and that's it. 4 and 2 would come next. I want to make them add up to minus 7, but it's going to be the 1 and the 8. And for it to be negative 7, I want to be plus 1 and minus 8. So I rewrite this now. 4x squared plus 1x minus 8x minus 2. Look at the first pair. All I can take out is an x, giving me 4x plus 1. I know that my second bracket also needs to be 4x plus 1. So I can take 2 out, and it's going to have to be a negative 2 to make minus 2 times 4 give me minus 8, and minus 2 times 1 to give me minus 2. That gives me my repeat, and leaving me x minus 2. So the top of that I can now write as 4x plus 1 over x minus 2. And the bottom of it, if I take out 4 as a common factor, it leaves me x minus 2. 4 times x is 4x, 4 times minus 2 is minus 8. And what that means is that I can then divide x minus 2, because you've got the same factor on the top, on the bottom. So you're left with 4x plus 1 on top and 4 on the bottom. You could have that in a bracket, that would be absolutely fine, or not, it doesn't matter. So you factorize the top using your quadratic method, you factorize the bottom using a common factor, and then you can cancel those. That's grade A work there. But even if you couldn't get 4 marks, you could definitely get 2 by factorizing the top. Okay, so solving an equation with a fraction. This is grade B. And if you remember what I told you, you're looking to multiply by the lowest common multiple of your fractional parts. So what's the smallest number that's in both the 2 times table and the 5 times table, which is 10. So I have to multiply every bit of it by 10. So 10 2x minus 3 over 5 is that part, plus 10 4x plus 5 over 2 is that part, equals 10 11 over 2. 10 divided by 5 is 2, so 10 over 5 means that simplifies to 2x minus 3. 10 divided by 2 is 5. 4x plus 5. 10 divided by 2 is 5. 11. So we've got rid of the fraction. Now we get rid of the brackets. So 2 times 2x is 4x. 2 times minus 3 is minus 6. 5 times 4, 20x. 5 times 5, 25. 5 11s, 55. I've got 24x plus minus 6 plus 25, same as 25 take away 6, 19. Take 19 off each side, and I get 24x equals 55 minus 19 is 636. Divide by 24, 36 over 24. They're both even. 18 over 12. They're both even. 9 over 6. 3 goes into them both. 3 over 2. So x is 3 over 2, or 1.5. You could leave that as 36 over 24. It's not telling you to give your answer in its simplest form. The key skill with that one that makes it grade B is to get rid of the fraction, multiply by that number that both 5 and 2 go into. Question 13. The cuboid has dimensions of 40 millimeters, 25 millimeters and 12 millimeters. All of these measurements are correct to the nearest millimeter. Okay, that's the trigger that you need to spot that would make this a higher tier question, because what that means is everything has been rounded to the nearest millimeter. So in fact that height of 12 could be less than that. It could be as low as 11.5 and it could be as high as 12.5. So we've got a minimum value and a maximum value, and that will be the same then for the other two measurements. So that could be as high as 25.5 and as short or as low as 24.5. And the 40 could be 40.5 or anything down to 39.5. Okay, so as soon as you see the measurement has been given to a rounded value, that makes it grade B. 4 of these cuboids are stacked together as shown below. Write down the greatest possible value of the length of A. So this is your A. The greatest possible value will be 40.5 millimeters. The greatest possible value of the length B, well, the length B has got 2 of these together, so it's going to be 25.5 plus another 25.5 if they're both at their maximum possible lengths. So that will be 25.5 plus 25.5, 51 millimeters. And for the least possible value of C, that means you want the height of this box to be as small as possible, which would be 11.5 and 11.5. So that would be 23 millimeters. Okay, so that's a really easy question once you spot that. If you fail to spot that, then the question becomes trivial. It would be 40, it would be 50, 25 plus 25, it would be 12 plus 12. There's no way on any GCSE paper you would be asked that question, even if it's foundation tier. So the fact that you're doing a higher tier paper, always look to spot that. Okay, and then finally, question 14, probability trees. Again, something that you've had to get your head around while I've been off. So Dylan is having a weekend break in Wrexham. The probability that he will visit Erddig Gardens is 0.7. The probability of Dylan going to Bersham Heritage Centre is independent of him visiting Erddig Gardens, so it doesn't matter whether he goes or not. The probability that he visits Erddig Gardens and goes to Bersham Heritage Centre is 0.28. Complete the following tree diagram. So he's either going to Erddig, which is 0.7, or he's not. The total probability there has to add up to 1, so that is going to be 0.3. Just press on there. Now, where you have to be careful here is with this second part. Okay, most common mistake people make here is not to read this carefully enough and just drop in the 0.28 there. The 0.28 is the outcome of travelling along this branch and travelling along that branch to give you here 0.28. When you're using the word and you're travelling in the same direction, you multiply the probabilities. So what you've got is 0.7 times something is 0.28. Just whipping through your 7 times table, you should get straight away, well, 4 7s are 28, so that must be 0.4. Once you've got that, straightforward then, these two must add up to 1, so that's 0.6, and then this is just a repeat of whether or not they go to the Heritage Centre, depending on what they've done with Erddig Gardens. Calculate the probability that Dylan visits Erddig Gardens but does not go to Bersham Heritage. So he's visiting, so he's travelling along that branch, and he does not, so he travels along that branch. So it's 0.7 and times 0.6. So 0.7 does not go to there, is 0.6. 7 6 is a 42, 2 digits after the decimal point in the question. So there'll be 2 digits after the decimal point in the answer. So that's a grade B probability tree diagram question. One little trap in it is reading it and recognizing that you're not going to put the 0.28 there. Okay, so that was the higher tier paper 1. I'll try and do a video solution for the paper 2 over the next couple of days and get these up to you by the end of the week. Okay.